Talk about section 6.3, geometric sequences and series. All right, so this is a fair amount of new vocabulary. It does connect to exponential functions because, as you'll see, geometric sequences follow an exponential pattern. But let's start off talking about the vocabulary, and we'll sort of ease into the different problem types that we'll encounter. All right, so the first word is a sequence, and a sequence isn't just an order. An ordered progression of numbers. It should be ordered progression of numbers. Okay, so it's a set of numbers that follows some pattern, right? A finite sequence is a sequence pattern of numbers with a finite set of terms. Terms are the numbers inside of a sequence. Okay, so finite just means it's a sequence where there's not an infinite number of terms. And that's actually the only type of sequence that we're going to talk about. We're not going to talk about infinite sequences here. I think if you go on to pre-calculus, they'll talk about infinite sequences. We are not going to deal with that here. All right, we will talk about series towards the end of the lesson because we're also going to talk about series. But here's a few examples of sequences. Okay, so some of them are very simple. 1, 3, 5, 7, ... just keeps going on, right? So, or maybe it doesn't. Maybe you just stop there. So like maybe that's your sequence, right? 1, 3, 5, 7. You see the pattern. The next number would be 9, right? Or here's another one. 2, 4, 8, 16, and so on. All right. So let's go to 32. Okay. So there's a 5-term sequence, and so it's just a set of numbers that follows a particular pattern. This one, it turns out to be a geometric because we're multiplying by the same thing over and over again. We're doubling it. We're multiplying the previous term by 2. So how do we get to 4? We multiply 2 by 2. How do we get to 8? We multiply 4 by 2, and so on. Okay. Now, to label each term in the sequence, we use a particular, a certain method for labeling. Okay. So to label the first term in a method, or in a sequence, we write a sub 1. Okay, the second term will be a sub 2, and then a sub 3, and a sub 4, and a sub 5, okay? So a sub 5, for example, means the 5th term in the sequence. So if I said, well, what is a sub 5? You would be like, oh, well, a sub 5 is 32. All right, so that's what that index number is just telling us which term in the sequence we're referring to, we're talking about, okay? All right, so let's do an actual problem now. In this one, we want to find the first 4 terms and the 100th term in the sequence a sub n, in which a sub n equals 2 times 3 to the n minus 1. All right, so let's do this. So the first term, a sub 1, will be equal to 2 times 3. Now, if I'm looking for a sub 1, the n that shows up here is the same as the n here. Okay, so if I want a sub 1, then I'm going to plug in 1 for n right here, very similar to a function. So it's 2 times 3 to the 1 minus 1. All right, well, let's simplify. This is going to be 2 times 3 to the 0. That's the same as 2 times 1, so this will just be 2. Okay, a sub 2 will be 2 times 3 to the 2 minus 1. That's going to be 2 times 3 to the 1. That's going to be 6. A sub 3 is equal to 2 times 3 to the 3 minus 1. That's 2 times 3 to the 2. That's 2 times 9. That's 18. And now at this point, you might be able to see the pattern. The pattern is that we are tripling each number, right? So 2 times 3 is 6. 6 times 3 is 18. And then our last one here, a sub 4, is going to be 2 times 3 to the 4 minus 1. That's going to be 2 times 27. Which is, or 2 times 3 to the 3rd, which is 2 times 27, which is 54. Okay, so there's the first 4 terms in our sequence. Now, if we want a sub 100, we can just go figure that out. We can just go a sub 100, and that will equal 2 times 3 to the 100 minus 1. So that we'll have to use our calculator to do that. So let's go to Desmos here. Sorry, I should have had this already up. So it'll be 2 times 3 to the 99 is all we need to type in. So let's go 2 times 3 raised to the 99. And so it's a really big number, obviously. So it will be 3.44 times 10 to the 47th. Okay. And I'll show that now. Okay. All right, let's do a word problem. Julian sees a band concert. He posts a link to the concert, to the band's website on his social media page. Then 5 of his friends post it. Then 5 each of their friends post it, and so on. If the pattern continues, how many will have posted it on the 8th round? And so actually, you know what? Let's table this problem until after we talk about the formula, because this problem is easier if we know the formula. So sorry for that diversion there, but geometric sequence is defined. So let's talk about a geometric sequence. Geometric means you're multiplying by the same number every time to get the next term. Like in this one, we were multiplying by 3 every time to get to the next term in the sequence. All right? These types of sequences follow a particular pattern. If you want the nth term, what you do is you take the first term times r, and r is called the common ratio. All right, called the common ratio. A sub 1, that's the first term. We already talked about that, to the n minus 1. All right, so this is the formula that geometric sequences follow. You can also always find r by taking any term and dividing it by the previous term if you know the sequence is geometric. So you can just always take the second term divided by the first term, and that will give you r. Right? Or you could take the fourth term divided by the third term. It doesn't just have to be the first two. The last bit of vocabulary here is geometric means, and I don't want you to get confused by this term. It's just the terms in a geometric sequence, okay? So we found 4 geometric means here, right? And so that's all geometric means. That's all that means, okay? So let's go back to our band concert question here. Julian posts this link. 5 of his friends post it. Then 5 of each of their friends post it, and so on. If the pattern continues, how about the 8th round? Okay, so let's pick apart what we're actually going to figure out here. A sub 1, the initial number of people that saw the link after it was posted was 5. All right. 5 of their friends post it, and so on. So if you imagine what happens, you post it, 5 friends share it, and then each of them posts it to 5 different places. So you're going to multiply that 5. It's going to get multiplied by 5. Right. So at the end of the second round, you'll have 25 friends will have posted this link, or the link will have been shared 25 times. So our common ratio is also 5 because we're multiplying the number of people that see the link by 5 every time. So our rule then will be a sub n equals 5 times 5 to the n minus 1. And so if we want a sub, what do we want here? A sub 8, all we're going to do is take 5 times 5 to the 8 minus 1. All right, and so if we go compute that real quick, 5 times 5 raised to the 8 minus 1, so the 7, that's going to be quite a lot of people, right? So that's going to be 390,625 people. Okay, so you can see the numbers grow pretty quickly when we're talking about exponential relationships, okay? All right, let's go on to number 3 here. Write an equation for the nth term of the geometric sequence. Now, I'm going to say this probably more in this video. You need 2 things to write an equation for a geometric sequence. You need a sub 1, the first term, and you need r. Right? You get those 2 things, you can get the equation. If you don't have those 2 things, you've got to go figure out what they are. Okay? So in this, a sub 1 is given pretty clearly. 0.5 is a sub 1. Right? What we don't have is r, but we can figure it out because, as I said over here, you can take the second term divided by the first term and you'll get r. So r will be equal to 2 divided by 0.5. That turns out to be 4. All right, so now I have a sub 1. I have r. I can write my rule. A sub n is equal to 0.5 times 4 raised to the n minus 1. Okay. For reasons that I'll go into a little bit more in class, we can't multiply these 2 numbers together. So for now, just don't try it. Just leave it as they are. Okay.